Okay. We got these resistors. We've also got a wire leading out here, and a wire leading out here, and a wire leading out here, and a wire leading out here. Now, and we have, you know, more circuit out here. This is just one little loop within a circuit. So we have current I1 here, I2 here, and I3 here. And for the heck of it, we have some voltage source here. We could also have a capacitor or whatever, okay? A little more complicated when we get capacitors. We'll talk about sources and resistances right now, okay? And you'll love the differential equations that come out when you have a variable source. Okay, well, so what's the total voltage drop from, I don't know, you tell me where to stop.
Like right there?
Okay.
I heard a bunch of words, I did not hear stop. Let's try this again. I gotta hear stop. If I hear, in the first place, I can't hear very well. Second place, I don't know if she's saying keep going or stop or what the heck are you doing, okay? So let's try again. Stop. Even, whoa. I can understand that. Anything more than that, I won't be able to process in time. Okay, here we go.
Stop.
We can't stop in the middle of a resistor.
Well, you know, right.
You said it here.
Yeah, right there.
Okay, we stopped there. This is point A.
You said the first time, I wasn't letting you do it the second time, and you redeem yourself.
What's the change in electrostatic or electric potential between point A and point A?
0.
Yeah,
Okay.
potential ain't changing, at least not at any instant, okay? Now, what's another way of writing this? Well, what's the change in potential if we go around the loop in this direction? Starting at A, we go around this way, right? What's my change in potential as I go across resistor R3? Well, what happens to the potential as we go across resistor 3 with current I2?
Doesn't it reverse it?
I mean,
Well, yeah.
the
Current, voltage, and resistance are related. How are they related?
I times R.
Yeah, except it's negative,
Ah,
because
yeah.
the
It
potential has to
reverses
go
itself.
down for the current to go in this direction, right? And then we continue around the loop. Well, this would then be negative right?
Right.
And then what's this? Well, we're going from positive to negative. Potential goes down, right?
Right.
By magnitude V. Okay?
Right.
Or the sum of the voltage drops is going to be equal to opposite to the voltage changes, right? In other words, a negative change in voltage is a voltage drop, and we usually think in terms of voltage drop. And this current through R2 is I1. Okay, so all these are positive, right? Now how can all these be positive and add up to 0?
They're all zero. Yeah.
Because the current's 0.
That's not necessarily the case.
Oh.
Obviously, you can have currents through these things,
Well.
okay? Well, the thing is, your voltage could be positive or negative.
Oh.
Okay? Now, if B doesn't have a positive sign, well, I gave you the positive and negative here, right? So you know V is positive. Okay? These positives, the some of the currents are negative. Okay? See, I chose all the currents being positive, right? Well, if there isn't anything else in here, you know that the current's going to be in this direction, and all those currents are backwards, right? Okay? Well, in this case, we actually have a couple more currents. We're going to have I4 coming in this wire, I5. It doesn't matter which way you draw them. I got two I6s. So we've got 7 currents in here. Okay? We've got 4 nodes. Each node, well, at this node, what do we got? We got I3, and I don't have a current through here. So I've got an I8 here. Okay? So what do we have? At this node, we've got an equation. I7 plus I3 minus I8 is 0, right? I4 minus I1 plus I8 is 0. And at each node, we have an equation. Okay? So, at our nodes, minus I8 equals 0. Okay? Now, if we assume we know the resistances, we want to have 8 equations so we can solve for the 8 currents. Okay? This node, we have I4 minus I8. No. I8 minus I4 plus I1 equals 0. Minus I1. I got the signs wrong. Okay? We want to be sure that we're oriented toward currents coming into the node. Into the node, we've got I4 and I8. So it's I4 plus I8. Out of the node, we've got I1. That's 0. Over here, I1 comes in, I2 goes out, I5 comes in. Now, it's to your advantage to do these in numerical order because you're going to have 8 simultaneous equations and 8 unknowns. Okay? A lot of unknowns are missing from any equation, so they're not as hard to solve as you might expect. Okay? And then we have, at this node, we have I6 coming in, and I'm just writing them in the order I see them. And I2 is coming in, as I say. You probably want to think about, I have to write it I2 plus I6, I2 minus I3 plus I6. Now I'm just getting it down the way I see it, and then I'll rearrange them in order, and I'll make spaces. Have a column for I1, a column for I2. It ends up being a matrix. Okay? Which is easy to row reduce. So we have these equations for our nodes. Okay? Then we have the equation representing the loop, right? Which is this. Okay? That's only 5 equations. We've got 8 unknowns. Okay? So what do we do about that? Well, we'll talk about that later. But the point is, you've got a loop here, okay? And you've got these nodes. And you can write out the equations, okay? And the other thing is, it makes no difference. Really not a good place to do this, so I'll kind of do it a slightly different color. Should have made this a little bigger. What if we've got this, another resistor? We'd have another current here, right? Okay. We'd have to account for that current at this node and this node. Okay? But whatever the current is here, that just affects what goes on at the node. It doesn't affect the fact that this is a loop. Okay? Doesn't affect the fact that the voltage drop around this loop is 0. But it gives us another loop. We have a loop here. Voltage drop around this loop has to be 0. Okay? Make sense? Now, we could then say, well, we got a third loop. We got this one, right? But this big loop is a combination of these two. So if you did that, one of your equations would be degenerate. Wouldn't add you any information. So it doesn't help to have a loop that's a combination of the other loops that you already have.
So it's better to just do the big loop instead of the 2 smaller loops.
You have the total choice. You can do the 2 smaller ones. You could do the big one and either of the 2 smaller.
Okay.
Okay? So get that idea firmly in your head.